Refrigerators are a common appliance found in almost every household, but have you ever wondered how they actually work? When food is kept at room temperature, bacteria can start to grow, causing it to spoil quickly. However, when food is stored at a temperature below 5 degrees Celsius, the growth of bacteria slows down, allowing the food to remain fresh for a longer period. For this reason, the refrigerator's temperature is always maintained between 0 and 5 degrees Celsius, while the freezer's temperature ranges from minus 18 degrees Celsius to minus 22 degrees Celsius. At such low temperatures, the growth of bacteria is halted, preserving the food for an extended period. A refrigerator works like a heat pump. It absorbs heat from the air inside and releases it into the surrounding environment. This process is made possible by several important components inside the refrigerator. The most crucial component is the refrigerant, a freezing liquid that flows through the pipes fitted inside and outside the refrigerator. The inner pipes are called evaporator coils, and the outer pipes are called condenser coils. The pipes are connected through an expansion valve. Additionally, the refrigerator contains a compressor, which plays a vital role in maintaining the continuous flow of the refrigerant through the pipes. The cooling process in the refrigerator starts when the refrigerant enters the evaporator coils inside the freezer. The refrigerant is a liquid with a low boiling point of around minus 22 degrees Celsius, and it can easily transition between liquid and gaseous states as it absorbs and releases heat. As the refrigerant moves through the evaporator coil, it absorbs heat from the air in the freezer. This happens because the temperature of the refrigerant liquid is lower than the air inside the freezer. Heat naturally moves from warmer areas to cooler ones, so the air in the freezer gives off heat to the liquid refrigerant, resulting in the cooling of the air. The cold air, being heavier than warm air, sinks and pushes the warm air upwards, allowing it to exchange heat with the refrigerant. This is how the cold air circulates inside the refrigerator. The refrigerator's fan plays a significant role in speeding up this circulation. As the liquid refrigerant absorbs heat from the freezer, its temperature rises to the boiling point, causing it to change from a liquid to a gas. The refrigerant gas then passes through the evaporator coil and reaches the compressor. The refrigerant enters the compressor as a low-pressure gas, where it's compressed into a high-pressure, high-temperature gas. This compression raises the temperature of the refrigerant to 100 degrees Celsius, making it ready for the next stage of the cooling process. The high-temperature gas then flows into the condenser located outside the refrigerator, where it releases its heat to the surrounding environment due to temperature differences. This causes the refrigerant to condense into a high-pressure liquid. Condenser coils are designed to maximize the surface area for heat exchange with the surrounding air. As the refrigerant gives off heat, the surrounding air absorbs it, allowing the refrigerant to cool down. Once the refrigerant's been condensed into a liquid, it enters the expansion valve, which is thicker than the condenser coil. This allows the liquid refrigerant to expand, causing its pressure to drop. This reduction in pressure causes the refrigerant's temperature to fall below minus 22 degrees Celsius, making it ready for the next stage of the cooling process. The cold, low-pressure liquid refrigerant then enters the evaporator coil, absorbs heat from the interior of the refrigerator, and evaporates into gas, thereby cooling the air inside. This cooled air is then circulated throughout the refrigerator, keeping the contents at a low temperature. The low-pressure gas, now warmed by the heat it's absorbed from the interior of the refrigerator, re-enters the compressor to restart the cycle. This continuous process of compression, condensation, expansion, and evaporation allows the refrigerator to maintain a consistently cool interior while expelling the absorbed heat into the surrounding environment. By harnessing the principles of heat transfer and thermodynamics, refrigerators play a vital role in preserving our food and enhancing our daily lives. If you enjoyed this video and would like to see more of it, please subscribe to this channel. Thank you for watching.